Hi, my name is Catalina Becerra, and this is my final project proposal. So, as you all know from my previous videos, the objective of my study was to analyze land use and land cover change from 2015 to 2024 that occurred in Laguna Club. This is the place where my house is located in Colombia, Cartagena. And the idea was to identify the impacts of infrastructure development, like buildings and roads, on forest loss. So the place where I live is quite small. I will show you later what it is. But in order to perform an accurate and meaningful classification, I selected a bigger area, which is inside this square, this purple kind of square that you can see here on the screen. And it includes other housing infrastructure, but it also includes forested areas, grasslands, and water. This is in northern Colombia, next to the Caribbean Sea. And well, I choose this area because over time, infrastructure has taken over forest and grasslands in this region. If you probably know, Cartagena is a very touristic city in Colombia, and infrastructure and hoteling is expanding over the northern part of the city where these forests and grasslands are located. Um, so my intention is to see whether or not this infrastructure has impacted forest, and most specifically where my house was built in an area previously covered by forest. As the landowners say that there was no forest in this area. Um, so this is the project location. Um, I created a polygon using ArcGIS Pro. As you can see, this is like kind of the purple square, but my house is located on the uh, top right corner of this imagery. And then again, this is in northern Colombia, close to the Caribbean Sea. This is an area that has basic two seasons, rainy season and dry season. The rainy season goes mostly from March to July, and then we get the dry season until October, and then the rainy season comes back again. So this area is heavily impacted by rains. We get heavy rains. We also get impacts from hurricanes and other forms of tropical storms, and fires as well. These grasslands and savannas, they get fire naturally, but also there's human-made fires to remove the grasslands, establish cows for livestock, and then once the area is totally degraded, they sell the land to build infrastructure. So this is the data that I use. I use Sentinel, and no, excuse me, I use Landsat 8 imagery, optical imagery, acquired for 2 points in time, one for 2015, that's in June, and the other one for 2024 in May. I tried to find images that were as close as possible in terms of time to avoid disturbances given the seasonality. I also tried to get Sentinel, and I did find a nice imagery, but I wasn't able to georeferentiate the image to my location. I tried different coordinate systems, the ones that make sense, but it didn't work out. So because I don't have much time, I decided to just stick to the Landsat. These Landsat are, of course, 30-meter resolution. They are taken by the um, um, only set for. And what you can see here, the different bands. I use the combination 543 to see the near infrared and clearly distinguish forest from non-forest. I only use ArcGIS Pro. To be honest, I didn't like much um, eCognition. I found it quite difficult uh, to obtain a meaningful segmentation. I didn't catch what could be a good combination for the segmentation. And then when I was building the key, I saw that the parameters that I was using were not totally exclusive. And as such, I got some areas misclassified, and I also got a huge class of unclassified areas, which I didn't like. I think the classification it's done easily in ArcGIS Pro. But yeah, that's the reason why I didn't use eCognition. But of course, it's quite interesting to run the segmentation there, but I just didn't like it as much, and also it was very computer consuming, or maybe I did something wrong. But yeah. So this is my workflow. I adjusted a little bit compared to my previous presentation. So I obtained the Lancet data set, and then I clip it to my project area, which I already show you. And then I use the training samples tool in ArcGIS Pro to collect samples. I collect samples for only 3 classes. I use forest, non-forest, and water. There were other classes like buildings and roads, but they were kind of mixed. And given that my imagery was not very high resolution, I decided to just use these 3 classes because in the end, what I really wanted to see was forest and non-forest. So I only used these 3 classes, and I collected about 20 samples per class. Then I decided to run a pixel-based supervised classification. I wanted to do an object-based classification, but the quality of my imagery was not as good, and I couldn't find naive imagery or LiDAR or well, and I already mentioned the issues that I had with Sentinel. And I think, I mean, working in areas in the US is quite nice because you can find all sorts of high quality data. But in other places, like here in Colombia or in other countries where I usually work, it's not the case. And I think this is more like the real life, especially for me. I work with developing countries, sorry. And well, so yeah, this is why I stick to the pixel base. So using my samples, I use the classifier, the train a maximum likelihood classifier tool in ArcGIS Pro. And then I classified the raster. I estimated the areas, and I replicated this process for the second imagery for 2024. And then I tabulated the results, and I prepared the map. So these are the results. So as you can see, the table on top corresponds to 2015, and then the one on the bottom, it's 2024. So as you can see, forest did decrease in the entire polygon. It went from 242 hectares. I'm sorry, but I think in hectares. It went from 242 hectares down to 149 hectares. It's like we lost like about 100 hectares during this time period. And then what I also found quite interesting is the water, because it increased from 48 hectares to 110 hectares. And I thought it was an error in the classification. And I did it like 3 times. I repeated like three times. But then I realized that most of these new houses and condos that are built here, they're also building artificial lagoons. And I think this is the reason why water increased that much. And then if you see here in the maps, so on the left you can see the map from 2015, and then you can see here on the right, it looks like it was low forest, it was all clear, but also looks like there is more water if you compare it to 2024. And I believe it's because of all the riparian forest, like the forest that grows alongside the rivers, it was clear. And now with the Landsat from 2024, I was only able to capture the water. So yes, unfortunately, the forest decreased, and as you can see, I put here on the red square a specific location of my house, and it is evident that some sort of forest was cleared, and also there was a lagoon was created, an artificial lagoon. And yeah, also in the southern part on the left side, it is evident that most of the forest was clear. And now if you go to the area, you can see that there's loads of hotels and fancy houses over there. But unfortunately, the forest is gone. And I don't know if hopefully if the 149 hectares that remain will stay standing, but there are more projects for housing and other types of infrastructure planned for this area. So it seems like it will disappear. To summarize, so I do believe that my results address the original problem, which was to see if there was some sort of impact from infrastructure development on forest, and I did find it. Forest was decreased, and what I can see on the field, I'm right now I'm here on this area, and it is evident that infrastructure is taking a place on forest here. So I was able to confirm that part of the place where I live was forest before, but it was mostly all grasslands. But then, interestingly, I thought the lagoon, this lagoon that you can see here on top, I thought that lagoon was natural. But then I realized that this one and other lagoons that are nearby were actually created to make it look more friendly, I believe, more green. So what worked well? I think the pixel-based supervised classification worked well. I followed the instructions of lab number 4, so that was pretty nice. What did not work well? Sorry, I missed the note. Was that finding high quality data and handling the Sentinel data, as I said, and also I wanted to perform an object-based classification, but just the quality of my data was just not enough. And then what I would do differently, I would dedicate more time to finding a solution to the Sentinel data and maybe reaching out to the professor to find a solution. Unfortunately, these past weeks have been extremely busy and I wasn't able to reach out and seek help. I could also have tried to find aerial photographs. I know that there's an institution here in Colombia that has this historical imagery, but then it is time consuming to prepare data and classify it. But I think that could be a good resource. And then, of course, I will have run an object-based image classification. And then the single most significant thing that I learned was, well, everything, pixel-based classification and object-based classification. I mean, for this specific project, of course, the pixel-based, but overall, in the class, for me, what was more interesting and useful was the use of Google Earth Engine. So I'm really thankful for that. And I'm really thankful for everything that I learned here. Thank you so much.